we continue talking about complex numbers. We looked at the representation of complex numbers on the number line in our previous video. Now, let's also talk about what I call the rectangular form and the polar form of the complex number. Now, the thing is, we have a complex number represented by z. Z is equal to a plus bi, where you have an x and y axis, but these are, in our case, the real and the imaginary axes. All right, so we locate a, if a is here and b is here. Let's put a out here. All right, so what we would have is a, we locate a, I'll go up to b, so we have b I, right? Now we have a plus bi on our diagram. Let's shorten it a bit now. A plus bi. So that's what we have. Our a is further up here. I didn't want to cross this margin, so it's look a bit neater when we don't cross the margin. Because remember, in exam they said do not write on or over the margin. All right. And we have a margin here. This is b. Let's shift b down a bit to make it look more lined up. All right. So our a plus bi. Now, when you look at it, you can say this a plus bi is either rectangular or polar form. Which is it? Let's see something here. You see the a? It can be used to represent the width of a rectangle, you know, and the b, the height of a rectangle. All right, if we draw the rectangle like that. So this a plus bi business here, we can say a is the width of a rectangle and b represents the height of the rectangle. As a is on the horizontal, the real axis, and b is on the vertical, which is the imaginary axis. So from that you can remember which is which. So let's write it over here. So z is equal to a plus bi is in the rectangular form. That's the rectangular form of a complex number, a plus bi. It can be 2 plus 3i, 5 plus 6i, whatever number plus number I. That is, and it can be minus. It can be a minus 2, right? 10 minus 15i, right? 75, negative 75 plus 150i, bigger number, small number, doesn't matter. 15 minus 5i, right? Number, these are still in the form a plus bi because this is 10 plus negative 15i. This is 15 plus negative 5i, and so on and so forth. So they are all in rectangular form. A plus bi is the rectangular form. But this polar form business, how does it come in? Let us see if we can get a polar form now. Here, this complex number. As you can see, you can form a triangle with it, alright? Where this width is A. Let's draw our A here. And the height is B. And we have an angle here. Let's use theta, Greek letter theta, to represent the angle. Alright? Now, you remember your trigonometry? Cosine of theta is adjacent, which is A, over the hypotenuse. Now the hypotenuse. Sometimes you might see R being used to represent the hypotenuse, because it's like the radius of a circle. If you should draw this complex number right around what you have is a circle. Although my circle doesn't really look too much like a circle, but it is a circle. So adjacent over hypotenuse, which is R. Alright? So in this case, if we transpose for A, we say A is equal to R cos theta. See that? Now, how about you pause the video, write the part involving B, and then write down the full complex number where you have Z equal something with R, right? Rewrite this with A plus BI to form what is called the polar form of the complex number. So pause the video and go right ahead and do that. Okay, you did that? If you did that, well, you should have done it. What you would have is what is called the polar form of a complex number. So let's see. The part involving B now. Sine theta is opposite. So theta is on the left hand side of a triangle, B is on the right hand side, and by the way, it's a right angle triangle. Let me put the symbol for the right angle here. Let me redraw it. Straight up, straight across. Alright. Sine theta is the opposite, which is side, which is B, over the hypotenuse, which is R. So transposing for B, B is equal to R sine theta. You see that? Now, remember, Z is equal to A plus BI. So Z equal to A plus BI. Now let's rewrite Z. Z is equal to A. What is A? A is R cos theta. Right? Plus B, which is R sine theta I. Alright. Although sometimes writing it like this, it looks a bit awkward to put the I on the right. Let's put the I on the left. I R sine theta. Alright, good. So this can even be written as Z is equal to R outside the bracket, and then cos theta plus I sine theta. Notice if we put I on the right, it might look somewhat like sine theta I, and we're finding the sine of theta I, but that's not the case. Right, we really find sine theta times I, but it's better if we just put the I on the left instead of on the right. So it's I sine theta. You see what I'm talking about? Now here, this is called the polar form. You don't necessarily have to put the bracket there. So let's label this as the polar form of the complex number. Alright? R cos theta plus I R sin theta. So Z equal R cos theta plus I R sin theta. Now what is R? Now in this case, R will be equal to the magnitude of the complex number, right? Or, well, in this case, R is equal to, this is also called the modulus of the complex number, or the absolute value of the complex number. So, modulus, also the absolute value of the complex number. Okay, so from here you can see theta would be, well, if you remember your trigonometry, tan theta will be opposite B over adjacent A. So theta will be tan inverse of B over A. So theta is tan inverse of B over A, right? R, which is the modulus of the complex number, will be the square root of A squared plus B squared. Alright, that's from your knowledge of from trigonometry. So in this case, we have rectangular form and we have polar form of the complex number. The two main forms. Let me put them in a box here. Z equal A plus BI is a rectangular form. Z equal to R cos theta plus I R sin theta is the polar form. Okay, you can calculate R by saying square root of A squared plus B squared. Right? And theta is tan inverse of B over A. So that is it for now. I'll see you in the next video.